New Flyer is a North American leader in transit bus design and manufacture. The diesel hybrid Excelsior 40-foot low-floor transit bus, designed and manufactured for the San Francisco Municipal Transit Authority, is an example of this leadership. This presentation will familiarize service personnel with the disc brakes on the Excelsior 40-foot hybrid bus. It will cover the rear hub and rotor service. The operators and maintenance guides that accompany the vehicle are the final authority with respect to safety, maintenance, and operational parameters. Consult the guides or your supervisor should you have any questions or require additional information. 3 types of headings are used in the maintenance guide to attract your attention. Danger indicates a hazardous situation which, if not avoided, will result in death or serious injury. Warning is used when an operating procedure or practice, if not correctly followed, could result in personal injury or loss of life. Caution is used when an operating procedure or practice, if not strictly observed, could result in damage to or destruction of equipment. These headings will be used in this presentation where appropriate. Safety. Service personnel must follow all Muni, OSHA, and New Flyer safety rules and regulations. Always ensure that the vehicle is appropriately hoisted and blocked for procedures that require elevating the vehicle. Note: components for the wheel end are extremely heavy. One must use caution and specialized lifting tools to disassemble and assemble the wheel end components. Only use tools that are in good working condition. Note: only use tools and accessories and genuine MAN parts that have been expressly approved by MAN AG. Note: final tightening torque of all fasteners must be performed manually using a calibrated torque wrench. For the purposes of this presentation, the balance of the video will feature an axle and brake assembly removed from the bus for better views. Wheel hub. The wheel hub consists of inner and outer tapered roller bearings, inner grease seal with integral ABS pulse wheel, and outer grease seal. The wheel hub is secured to the axle spindle with a locking slotted nut. The wheel bearing clearance is preset and non-adjustable. The bearings have a lifetime grease filling for lubrication. The wheel bearings require lubrication only if being replaced. Wheel hub bearing inspection. Raise the vehicle and support the rear axle on jack stands. Ensure the brakes are released and the wheels can rotate freely. Attach the base of a magnetic dial gauge to any rigid part of the vehicle structure or axle housing. Align the dial gauge pin perpendicular to the face of the brake rotor and as close as possible to the outer edge of the brake disc. Also, ensure the dial gauge pin is located at either the 6 o'clock or 12 o'clock position. Note: it is important that the dial gauge pin be positioned at the correct distance from the center of the brake disc in order to obtain an accurate reading. The tip of the gauge should be resting approximately 8.25 to 8.5 inches, 210 to 215 millimeters from the center of the disc. Zero the dial gauge. Grasp the wheel at top and bottom and rock back and forth while observing the dial indicator reading. Note: if clearance issues resulted in the dial gauge being positioned somewhere other than the 12 o'clock or 6 o'clock position, then ensure the wheel is grasped at a location that corresponds. As an example, if the dial gauge was located at the 2 o'clock position, then grasp the wheel at the 2 o'clock and 8 o'clock positions and rock back and forth. If total movement exceeds 0.010 inches or 0.25 millimeters, remove and inspect the wheel bearings for wear. Replace worn components as necessary. Brake disc rotor. Lateral runout inspection. Due to different application of brakes for different driving conditions, rotors may develop runout. If the runout is below the permissible level, 0.15 millimeters, the rotor does not need to be renewed. The rotor should be skimmed and reused up to the minimum rotor thickness allowable. Measure the distance between the pad and tappet on both sides of each caliper. The distance should be more than 1 millimeter. Measure the wheel hub play. Make sure the hub play is within the acceptable range. Mount a dial gauge with magnetic base to a rigid location. The tip of the dial gauge must be perpendicular to the rotor. Position the tip 35 millimeters down from the outer rim of the rotor. Rotate the rotor a complete rotation to find the maximum runout. The maximum allowable runout is 0.15 millimeters. If the bus is vibrating due to warped rotors, turn brake rotor on vehicle. Take off only the material needed to achieve an even contact pattern. This repair option is not only cost-effective, but also the better remedial measure because new brake rotors can always deform during the initial phase of use. These deformations are permanently eliminated by turning and will not subsequently reoccur. Hot spots on the frictional face cannot be removed by taking off small amounts of material. If a rotor is affected by such hot spots, it must be replaced. Caging the brake chamber. Using a 19 millimeter socket, cage the rear brake chamber by unscrewing the release bolt. Note: do not exceed a force of 74 foot-pound torque during caging. The chamber is caged when the head of the release bolt extends approximately 1.36 plus or minus 0.12 inches beyond the surface of the brake chamber. Warning: wheel brake failure can result due to a defective combination brake chamber. Removing the brake chamber. Using a 24 millimeter socket or wrench, remove the brake chamber mounting nuts and discard. Clean the mating faces of the brake chamber and the brake caliper. Move the brake chamber away from the brake caliper. Insert a clean, suitably sized plug into the brake cylinder bore on the brake caliper or cover with a piece of tape. Inspecting the brake chamber. Check the tappet chamber for dirt. The tappet chamber must be free from dirt and water. Inspect the seal protrusion. Note: if the seal protrusion does not meet the required specification of 3 millimeters, the chamber must be replaced. Careful attention is needed. Note: replace the brake chamber retaining nuts each time the brake chamber is removed. Disassemble brake pads. Remove the disc pad retaining lever, pin clip, pin, and lever.
I'm going to be careful here when I'm pressing. Bridge.
Note: it may be necessary to increase the pad running clearance to facilitate disc pad removal. Disassemble caliper and carrier assembly from the axle housing. Using a breaker bar and a 27 millimeter socket, remove 5 caliper carrier bolts and loosen the 6th bolt, but do not remove. Using extreme caution, with the aid of a lifting device, carefully remove the last bolt securing the carrier to the axle housing. Remove the carrier with the caliper and the backing plate from the axle housing. Place the carrier and caliper assembly on a working area. Caution: this assembly is very heavy. Discard all carrier bolts at this time. Removing the axle. Using a 22 millimeter socket, remove 10 axle retaining bolts. Discard mounting bolts. Use extreme caution when removing the axle from the axle housing. Note: the axle is very heavy. Inspect axle flange seal area and axle splines for damage and wear. Clean all mating surfaces. Note: the axle shafts are of unequal length and not interchangeable. Ensure that each axle is identified as to its location. Removing rear hub and rotor assembly. Using a round punch or drift, remove the dimpled, indented area in the retaining nut. Note: make sure the dimpled area is clear of the rotational movement of the nut in relationship to the axle housing cutaway. Using man tools to create the centering tool, insert tool into axle housing until it fits flush with the shoulder.
Then we just snug it up.
Snug the inner retaining bolt on the man tool using a 19mm socket.
And then of course these
Install man tool over the previously installed man centering tool. Removing the hub retaining nut. Install torque multiplier on the man centering tool assembly. Install the retaining washer and bolt. Install the man support bar on the torque multiplier and secure the bar to the torque multiplier with 2 retaining nuts. Position the bar in the opposite direction of hub nut rotation. Using a 22mm socket placed on the torque multiplier screw nut and with the bar positioned in the opposite direction, rotate the hub nut counterclockwise to loosen and remove the hub retaining nut.
video.
Remove all the special tooling. Removing thrust washer and installing axle housing hub removal tube.
This is the hub retainer.
Remove the hub nut and the thrust washer. Discard hub retaining nut. Install the man tube onto the axle housing threads. Turn the tube assembly all the way on until it abuts the hub bearing.
Never want to force it.
Note: make sure the thrust washer has been removed. Removing hub and rotor assembly. Lubricate the axle housing tube thoroughly with light oil. Pull the hub and rotor assembly off the housing and onto the tube. Depending on the position of the axle, and with the help of another person and a specialty lifting device, remove the hub assembly with the rotor attached from the axle housing tube. Note: the unit is extremely heavy and caution is highly recommended. Caution: use proper manual lifting and bending practices to avoid personal injury. Using a lifting device, place rotor and hub assembly on a workbench. Inspect axle housing and ABS sensor. Inspect the axle housing for wear, discoloration, and general serviceability. Note: inspect carefully the bottom area of the axle housing where the bearing sits, as this is where most of the weight is placed. Inspect the axle housing threads. Inspect ABS sensor cable, clamp, and mounting bolt for damage, wear, and secureness. Using a 4mm Allen socket, remove and replace sensor assembly if necessary. Removing hub from rotor assembly. Mark the position of the hub and rotor before separating both components. Doing so will aid in easier assembly positioning when reinstalling. Depending on the vintage of the hub, use a 14mm Allen socket or a E20 Torx socket to remove 10 hub to rotor mounting bolts. Note: inspect all rotor to hub mounting bolts. If the bolts are in good condition, the bolts can be reused. If the bolts show any sign of damage, replace with new ones. Separate the hub from the rotor assembly. Clean all components and inspect as necessary. Removing bearing snap ring and O-ring from the hub assembly. Position the hub assembly on a working area. Using an angled hooked removing tool, remove the bearing snap ring located in the center area of the hub where the bearings come together. By removing the snap ring, the bearings can be removed separately. Remove the O-ring from the inside of the inner bearing assembly. Discard the bearing O-ring. Pressing out the outer bearing and seal from the hub assembly. Position the hub assembly on a press. Position the man press out device, pressing handle, and press out washer into the inner bearing, and adjust so the jaws of the pressing tool positions into the snap ring groove of the bearing or just on top of the bearing. Press out the tapered roller bearing and radial shaft seal. Note, when pressing out the bearing, make sure the bearing falls to a cushioned surface. Hitting the floor or a hard surface will damage the bearing.
Okay, go ahead.
Pressing out inner bearing and seal from the hub assembly. Turn the hub assembly over and position hub assembly onto the press. Position the man press-out device, pressing handle, and press-out washer into the inner bearing and adjust so the jaws of the pressing tool position into the snap ring groove of the bearing or just on top of the bearing. Press out the inner bearing and seal. Note, provide a cushion when pressing out bearing to prevent damage when it falls. Pressing out inner bearing from inner seal. Position inner bearing and seal on a press with the ABS tone ring facing up. Position the man press-out device, pressing handle, and press-out washer into the inner bearing and adjust so the jaws of the pressing tool position into the snap ring groove of the bearing or just on top of the bearing. Press bearing out of inner seal. Note, provide a cushion to prevent the bearing from hitting the floor. Note, the inner seal has the ABS tone ring attached. The outer seal is a single lip seal with no accessory attached. Wheel bearing information. Note, if new bearings are being installed, perform an inspection of all new parts. If the bearings are not going into service, they must be wrapped for storage. If the bearings are going into service, a clean area free from dust and dirt is needed to perform the bearing grease repack. Note, careful attention to detail is needed to repack the wheel bearing with proper grease and correct distribution amount. Extreme caution is needed at this time. Wheel bearing grease information. Caution. An excessive quantity of grease leads to excess pressure and leakage in the wheel bearing. Do not exceed a grease quantity of 3.9 ounces or 120 grams. Apply high temperature grease MAN 284 LiH2 on the tapered roller bearings. Fill the cavity between the tapered roller bearing with high temperature grease MAN 284 LiH2. The MAN 284 grease that is currently being used is Fuchs Renault LX PEP2. Installing inner seal and bearing. Position the hub assembly on a press. Insert the tapered lubricated roller bearing into the wheel hub. Assemble the man pressing bushing with the slip-on handle and the washer. Press the radial shaft seal with the ABS pulse wheel into the wheel hub so that it seats flush. Installing outer seal and bearing. Position the hub on the press and install the lubricated outer bearing in the hub. Note, position the seal with the oil side of the seal towards the outside of the hub. The closed side of the seal faces the inside of the hub. Assemble the man press-in plate with the slip-on handle and the washer. Press in the radial shaft seal so that it is flush. Installing bearing retaining ring. Clip the retaining ring for the wheel bearing into the groove. Verify that the ring is locked into the two inner bearing races.
See the gap there?
Note, you must confirm snap ring is in the correct position in both bearings. Install inner bearing O-ring and assemble rotor to hub. Install lubricated inner bearing O-ring.
Using some of the green grease.
Assemble rotor to hub with marks in alignment. Install hub to rotor retaining bolts. Note: inspect all rotor to hub mounting bolts. If the bolts are in good condition, the bolts can be reused. If the bolts show any sign of damage or wear, replace with new ones. Hub and rotor are now ready to be installed on the axle housing. Installing hub and rotor assembly. Install the man guide tube on the axle housing.
On my head this.
Lubricate the guide tube with light oil. Thinly apply Molykote D high-performance lubricant in the wheel hub bearing seat area on the journal. Using a lifting tool or support, and with the aid of another person, fit the wheel hub with brake disc over the guide tube and onto the axle journal. Note: do not pull back on the hub, as the O-ring may dislodge. Remove the guide sleeve. Installing hub retaining thrust washer and hub nut. Install the thrust washer and a new hub nut. Turn the hub nut onto the axle threads as far as possible by hand. Note: a new hub nut must be installed every time it has been removed. Install centering device. Insert the man centering device into the axle journal until the stop is reached. Snug the centering device. Fit the grooved nut socket over the centering device and onto the grooved nut. Put the man torque multiplier with the assembly lever on the man grooved nut socket and secure using the man hexagon bolt and washer. Install the support bar on the torque multiplier. Tighten the grooved nut to 1200 Newton meters or 885 foot-pounds. That would be 110.5 foot-pounds on a torque wrench connected to the man torque multiplier. Turn the wheel hub constantly while torquing. Note: use a calibrated torque wrench for accuracy. Remove the special tools when complete. Indenting the hub retaining grooved nut. Indent the collar of the grooved nut into the stub axle groove. Note: do not break the flange of the grooved nut or the grooved nut will need to be replaced. Note: a new hub nut must be installed each time.
Looks good. That's pretty good.
Torque mounting bolts to 207 foot-pounds. Installing the axle. Install a thin coating of 3-bond white sealing agent to the axle shaft flange and wheel hub mating surfaces. Insert the axle shaft into the axle support, rotating slightly if necessary, to insert the shaft into the differential gears. Note: install 10 new mounting bolts and tighten the mounting bolts to 265.5 foot-pounds or 360 Newton meters. Install disc brake and caliper assembly with carrier. Use the man lifting tool to mount the brake caliper with the carrier on the axle housing. Note: the unit is heavy and assistance is recommended for installation. Install new mounting bolts and tighten them to initial torque of 250 Newton meters or 184 foot-pounds. Tighten the mounting bolts to a final torque of 390 Newton meters or 287.5 foot-pounds. Special note: when torquing the carrier bolts, the angle starting from 184 foot-pounds to reach 287.5 foot-pounds must not exceed 60 degrees. If movement to achieve final torque exceeds 60 degrees, the bolts may have been stretched and need to be replaced. Repeat the 2-stage torquing procedure in such cases. Remove the fixture when complete. Install the brake chamber. Remove installed protective covering from caliper brake chamber mounting hole. Inspect the brake caliper cylinder hole for dirt and contaminants. Clean if necessary. Apply white lithium grease to the spherical cap and